Thank you for inviting us and having such a great honor to present our knowledge and slides for this conference. So my name is Jang from Coreline Soft, and I want to discuss about the long nodule detection, so the current AI LCS performance and beyond the high-risk groups. So our company is like AI-based lung cancer screening and various chest disease monitoring and diagnosing company. So it's based on South Korea, and we are currently mainly focusing on K-Lucas, the LCS program in South Korea, and Hanse in Germany, and Foreign Longnan in the European Union. So let's go into the details. So let's say we have a performance of we have a performance of 92 or 94% of sensitivity based on the 1.4 false positive per scan. So do you think this is quite a decent or a nice performance? I think so. So this is the current AI performance based on the AI application. However, let's do some mathematics here. So we have a database here, which is called SNUH dataset. And this is composed of 398 scans. So the number of nodules are, the number of nodule scans are around 200. And there are 323 nodules. So basically it's like almost one nodule per each scan. Just like dividing those things. And if we calculate this kind of nodules for the 1.4 false positive per scan, we get the 955 nodules found. However, the 94% or 92% of sensitivity calculates the 304 nodules or true positive nodules that are found. That means if we divide 304 by 955, we get a positive predictive value of 32%. So this means if you use AI algorithm, you get 3 nodules. Then only 1 nodules are the ground truth and the 2 are false positive. Why this happens? Because it is like the prevalence of the nodules. So let's go to the next slide. So if we have a private data set for the mass detection, and its performance is really good. So you can see the current AI mass detection performance is like almost perfect. And for the metastatic cancer, we have a paper published on the DIR, and it is like we can diagnose and calculate the nodule volume and diameter and various things in a very accurate manner. But if we go to the incidental nodules, like incidental pulmonary nodules, let's see the left images. So you can see the left images like there's a cardiac sense, and you can see the nodules that are circled. And this AI algorithm has performance of around 0.9 sensitivity per 1.4 false positive per scan. So it's basically similar performance of the previous slide that I have calculated a little bit more. But if we go to the mathematical again, we get the 348 scans. So the number of nodule scans are 199. And there are only 64 nodules. Then if we calculate the scans, 1.4 false positive per scan with the scan number of scans, we get the 835 nodules. But actually, we have a 0.89 sensitivity, so there are 57 nodules are true positive. This yields the number of 6% of PPV. So why this happens? This is also because of the prevalence of the nodule. There are, as these nodules are found instantly, the number of nodules are very small, so it has low number of PPV. So how can we solve these problems? The first 2 lines are just like the current performance of AI scans. AI can detect long nodules as well as masses with high performance, and AI can assist radiologists beyond screening, like incidental or other some kind of medical circumstances. However, this kind of lung cancer screening is I searched on at my seat, and there were like 2,000 cancer cases per 50,000 patients in the NLST trial in the NEJM. So there were a little like an imbalance of the classes. So only the high risk group is not enough. We need higher risk group. we need highest risk groups for the nodule management and screening settings. So we of course we have like long RAS category for the nodule and mass based risk management, but we need some kind of other management plans for the clinical information based strategy. Yeah, that is the our message. Thank you for your listening.